Namaskar, hello and a very warm welcome to CIET NCRT's live phone and interactive program. This is a 5-day online training on ICT for teaching learning of mathematics. I'm Tanvi Khurana and let me tell you that this entire training has been organized by CIET, that is Central Institute of Educational Technology, NCERT, New Delhi. This training started on 14th of October and till 18th of October, every day from 4 to 5, we'll be bringing you a new topic every day. So today is the third day of this online training and the topic that we are going to discuss is FOSS for the teaching and learning of mathematics. Day 1 we have discussed already ICT for teaching and learning of mathematics, policy perspectives, need and scope. On the second day we discussed audio and video resources for the teaching and learning of mathematics. Today we are entering into the day 3 where we are going to talk about FOSS for the teaching and learning of mathematics. On day 4, that will be tomorrow, the topic of discussion is going to be immersive technologies for the teaching and learning of mathematics, and on the final day, that is the 5th day, the topic of discussion is going to be digital games and apps for the teaching and learning of mathematics. At this point, you're watching us on our YouTube channel, that is NCERT Official. If you have any questions, any queries regarding this entire training or the particular topic that we are going to discuss today, please reach out to us. You can simply write down your questions in the live chat box of our YouTube channel or you can call us on our number. The number is 8800440559. And if you want to email us your queries, the email ID would be training.helpdesk@ciet.nic.in. So till 5 o'clock we will be having an expert with us and he'll be solving all your queries, he'll be answering your questions. So please reach out to us and share your questions. Towards the end of the program, I'll be letting you know that how to register yourself, how you can be a participant in the post-assessment quiz. And the course link will be given to you on the last day. All the details will be mentioned in the session only, but towards the end of it. So please wait for it and watch the entire program. Now let me please introduce you to our guest for today. We have with us Dr. Madhu B. Sir, a very warm welcome to you.
Namaste, madam. Namaste. Namaste, audience.
Namaskar, sir. Sir is an assistant professor from Regional Institute of Education, NCIT, Mysore, Karnataka. Sir, once again, a very warm welcome to you and let's begin this discussion. We are very eager to know the details of this entire program and we would like to know what is it that you have in store for all of us regarding the topic that is FOSS for the teaching and learning of mathematics. Sir, shall we begin?
Yes, madam. So, thank you for nice introduction. So, last 2 days before when Vasalva sir and Angel ma'am was interacting, that time it was I think there was a query came regarding that about what are the tools suitable for mathematics, and that time it was told that there will be a session for that introducing the various ICT tools on mathematics which teachers can be used. So this session is actually for that one. This is based on free and open source tools. We are going to do with free softwares and at the same time open source softwares. So there is a difference between free and open source. Many tools which I will be introducing 3 tools mainly because of time constraint, and these among them 2 are actually free softwares which anybody can use, anybody can download, and another one is a open source one, free as well as open source. That means you have even freedom to change the source code of that one. So there are 3 tools we will be introducing this in these sessions. So shall we start with the basic idea that actually we know that NEP 2020 is on this one, and actually we are going to move to an digitally empowered society. So what we have to do is we have to incorporate technology in our classroom. And how it can be done, that is a very serious question to that one, and why we should do that one. Last 2 days we have interacted with these questions, but quickly I will go through that what is the just for using ICT. One is it is interactive, where the normal classroom, when teacher is doing some work, so especially geometry or something, the classroom will be more static. Teacher will be drawing a figure on the blackboard and they will be explaining the figure. But if they want to speak about this figure is changing, it is difficult to show that one. So our ICT will help you in making it more dynamic. And at the same time, student can interact with that tool. They can themselves play with that one, work around that one, and get some idea of how it is happening. That is one thing. Second is advantage for that one is it will enhance your problem solving skills. You can ask little more. Once you have a clear conceptual visualization with you, then you can have problem solving skills will be improved. Along with that one, there will be a collaboration we can have and better communication will be having when you are going for ICT. And but at the same time, we should also know that one there are some problems. Almost studies are saying there are some issues with that one. One is when you come to a new technological tool, ICT tool in the classroom, there will be a serious adaptation problem. The children will be facing how to use this technology, and teachers will be also facing this one. I think the teachers here may be knowing that more than teachers, more than students, teachers will be facing the problem for using this adaptation problem will be for more for teachers, and actually parents will be also watching. I think they will be also able to tell that their children will be good in techno, they will be more techno savvy, but at the same time the teachers or parents may not be that much. And at the same time, sometimes this kind of ICT tools of something like videos or something we are showing, there is a chance for getting distracted from the learning concept. So we have to reduce this kind of problems also. So what we are going to do is I will introduce three tools which can be used for classroom, which will be very less adaptation problems will be there, and we can more focus on the learning concept. The first one is RoboCompass. Okay, RoboCompass is a tool which we will be discussing about interfaces of RoboCompass. Then I will demonstrate one activity from the class 6 maths textbook using RoboCompass, and also we will try to list some basic tools in RoboCompass in this limited time. So later you can explore RoboCompass yourself. RoboCompass we can get. I hope you can see my screen.
Yes,
this
sir.
will be the interface of RoboCompass. So this, once you open RoboCompass, you will get a page like this. Okay, you can see a graph paper and command lines are there. So what I can do here is I can type, you can see a grid, graph paper type of thing here, where I can plot the points or anything. I will do a very small activity to get you familiarized with the tool. So I want to mark a point. So what I will do is I will type in the box a point and write its coordinates. Coordinates, for example, I am typing 3, 4. So you can see the point is coming there. A point is there. Similarly, another point B is equal to point. This time I will make some other point, say 6, 7. Third point, this time it is -2, 6. So I got 3 points. Now I want to measure the distance between A and B. So there is a command. That command I will call distance. DIST. So you can see that when I am typing, it is actually giving you the idea what I should do. You see point, what are the things I should do. So I am giving A, comma B. Now if I enter, I can see that value here. You can see the value coming here and distance. Suppose I don't want to show that one. It is very easy here. You will just hide this D. That is why I give name to hide this one. So I can hide this one. Now if you want to draw a polygon for a triangle, I will P equal to, you can see polygon coming here, polygon, then A, B, C. So you can see a polygon here. The polygon's name is P. I can see a triangle in one. Now, with this one, I will do one more small activity. I will take D equal to point, say 4, 0, E equal to point 0, 5. So you can see these 2 points standing on these two sides, D and E. Suppose you want to change the point to somewhere here. We can edit that one. We can make it 0, 7. The point E will change. Now next, what I am going to do is I am joining a line. I am going to draw a line. A equal to line. Then there are many methods. What I will do is I will D, comma, E. Then it will ask for some length. How much length? Actually, what I am going to do is I am going to draw a line passing through D and E. It will ask what length you want. So I am making it 10 units or something. So I got a line. Okay. So now you can see that this line is actually cutting the triangle which I have constructed. So now I want to make this cutting one region only. I want to show on the screen. So what I am going to do is G equal to part, P is my polygon, intersect P, comma, A. That is P and A are intersecting. P is the polygon, A is the line. 2, then again intersect P, comma, A, comma, 1. Then one more information I want. Actually, I got the two intersections. Actually, I cut this one. But now I want to show which one I want to show. I will mark here. Enter. Then I can hide the polygon P. I can even hide A also. So you can see the cutting portion only. You can see that whatever we have cut only we can show that one here. So this is one activity which I want to quickly demonstrate because this activity's advantage is you can see that almost many tools we have explored. Now, one more activity which I want to do is there is a class 6 textbook. There is a problem. That problem is in Ganitha Prakash, our grade 6 new maths book. There is a problem to construct a rectangle. We want to construct a rectangle, and what information we have is its diagonal divides the opposite angle into 60 degree and 30 degree. So let us see how we can do this one. So already I have constructed this one. I will just demonstrate this activity. So once I can log in using my Google Mail in this one. So you can see my name here. Whatever works I have done, it will be appear in that one. In that one, I can open this activity. Now, actually, now you can see the advantage of RoboCompass using in the classroom. Normally, teachers want to show that how a construction is done, how you are going to construct a particular thing to the students. And we want to repeatedly show that one for the students to see how they can do the same construction themselves. Let us see how once teacher is constructed. Construction steps are here. We can see how it is constructed to the class. You can see the instruction coming on the top. Mark a point A. Then mark a point B. Then you draw a line segment AB. Then we will draw a perpendicular. Another, we will make an angle. So you can measure the angle through protractor also. That we will see later how we can measure this one. Another perpendicular. Then we will take the point of intersection. Then again, there is a perpendicular we are going to draw. You can see how the protractor means how the set square and scale is moving, which will help the children to see how they can also demonstrate, repeat these steps. Now we can hide all the unnecessary drawings in that one. Then the students can see how this construction is actually happening in this one. So you can see the complete construction from this one. This RoboCompass is a software developed by Disk Technologies. So it is a very useful one. You need not download or anything for this one. You can work in your browser. Almost all the works I am doing in my browser in this one. So now you can see there is a line coming, and we can show there is a angle also I can mark with a protractor. So measuring of protractor, using protractor also we can show how it is working. So this is the brief introduction of this software RoboCompass, which is an open source software. Okay. These are the steps which I have done for that construction, but it is already shown there. So we are not going to see that once again. Now we will go to the next tool. That tool is called Desmos. It is actually done by a mathematician called Eli Lubarov, and this is also a free software, so which you can use very comfortably. Children will be, it is very powerful one. It is very easy to construct with this one. So it has a graphing calculator part, and where you can do graphs, you can plot multiple functions, parameters, and you can do that its behavior in real time. You can see what happens when you change the values. Quickly you can see that one. It is actually stronger than RoboCompass. And as I told you, it is accessible for everyone, and it is free. It is a free software. Now let us see how we can do that one. Second. Yeah. So if you open RoboCompass, this will be its interface. First you will see this interface like that. There is maths tools are there, also resources are there. So again, I have logged in with my Gmail account in that one. So my name you can see here. There are many maths tools are there, graphing calculator, scientific calculator, many things are there. You can yourself, we can explore those things. At the same time, what we are going to do is I will open the one graphing calculator. Some very brief small works we are going to do here. Okay, so I want to draw a straight line. So what I will do is I will, you can see that input bar here, there I can go y equal to 2x plus 1. You can see the line is coming, the straight line is coming here. I did not do much thing, just type the algebra, its geometry is coming on the other side. So it is very easy to do that one. Now I am going to demonstrate one of its interesting power of this one. This time, instead of y equal to 2x plus 1, what I am going to do is I am going to type y equal to mx plus c. So when I type mx plus c, immediately it is asking what is this m and c. So m and c is actually sliders, which I can change the value for that one. So it is asking, can I add sliders here? Add slider. So I will tell all sliders I want. So what is the advantage? Now you can see this one is red color, red line is side, there is a red color. I can hide the red one. Now I can change this value of m. You see, as I change, that is what we told that real time we can see what is actually happening in this one. Once you change this one, it is varying. Similarly, as I move C, it is changing. So that is the advantage for Desmos, its sliders. Now one more activity, one or two activities we will try to do with Desmos. This time what I am going to do is I will add y equal to ax square. It is asking what slider shall I add a slider to this one. You can see there is a triangle thing, danger mark or exclamation mark coming in here. That is saying that actually there is some mistake in your construction. This construction is not complete. So problem is they don't know what is A and B plus C. Now you add A, B, C does not come. So we'll see what happens if you change. You can see this parabola. Yeah, C is already, we have defined, that is why C is already coming here. You can see what happens to this shapes in this case. As A varies, what happens to the parabola? This is a quadratic equation which is coming in class 10. You can discuss with the students what actually happening in this particular topic. When you move A, B, C, what is going to happen for the parabola? When this parabola will cut the x-axis, when it does not cut the x-axis, everything student can explore themselves and they can come with their own observations for this work. Now, one more activity with this one we will try to do is, this time I will make x to the power n. It is asking add slider, okay, n. Now I click on n, it is asking what value to what value I should add, and it is asking for steps. So I am making n to 10 or n to okay, for the time being we will make n to 30, and it is asking which step, what is the increment I want to give for that one. I am giving 1. Okay, now you have a slider. Now you can see the graph also at the same time. Now I am going to move the slider. N equal to 2, it becomes x square, x cube, x cube, x raised to 4, x raised to 5. Now you can see that how it is moving. Actually, this concept is any child who is playing with this one can do. Any student of basic understanding of graphs can observe the features, but it is actually an advanced idea of sequence of functions of which is coming in the postgraduate level or undergraduate level students. So that means this tool we can use for any level of classes, not even for primary, higher classes also we can do this tool. We can work with this tool. So this is, let me try with one more activity. Now that is what we have done with sliders. Then I will open this 3-dimensional geometry for this one. Desmos has 3-dimensional geometries also there. You can see I have drawn 2 graphs. These graphs, one is x square minus 2 and another one is sin x. Okay, but actually what I did is I did it in the graph paper, but it's a 3-dimensional case. Z-axis also you can see here. If you hold like that, you can see x-axis, y-axis and z-axis. So you want to discuss about 3D, you can extend this one to 3D, extend to 3D. Also you can extend to 3D. So that 3D is also possible in this one. Now I think you can explore this 3D yourself, how we can do with 3D on Desmos. So this is the second tool we want to discuss in our brief time. Actually, each of this one, actually we should at least have a more than 1 hour session, or it should have a hands-on session to explore more. Because usually in our training programs, this offline training programs, we used to have a long hands-on sessions for each of this one. At least 2-3 sessions will be for RoboCompass, at least 2-3 sessions for Desmos. Now, what we are going to do is the third one which I am going to introduce is one of the strongest tool among all these, that is GeoGebra. some of our viewers may be familiar with this software also. This is one software was actually developed by Marcus Hohenwater, and now it is in the all world people are working on this software. This is the software which is open source, free as well as open source. RoboCompass and Desmos are actually free softwares. This is also open source. Its code is also available to us. Also, what is advantage for this one that we will see? One is it is a free open source which is for helpful for teachers to teach maths and science. The one is like Desmos, it is also dynamic and it is interactive. You can interact with this work. And it is a multidisciplinary. It is not only for mathematics. Science teachers can use it. Even social science teachers used to do work in that one. In resources, if you go to this one, you can see there are teachers are working with social science activities are there in this one. In our RI itself, we have made a cross section of I to teach biology for showing through GeoGebra. Some activities we have done not now, not recently, earlier. Then it is free and open source, and we can visualize the concept very beautifully. Then it will support inquiry-based learning. Now we will slowly explore GeoGebra. Once you open GeoGebra, again, I have already registered. So it is showing my one profile picture here. So it is teach and learn maths in a smart way. There is calculator, there is number of resources, then there are maths resources are there, classroom collaborations are there, how to make maths interactive. You can see the Pythagorean, explore the Pythagorean relations here. You can see how it is happening here. So it is already a demonstrated one. You can see how it is working. Similarly, we can engage students. It is also having linking with various other tools also. So we will try to explore some of the features of GeoGebra in more detail. So GeoGebra, as I told you, GeoGebra is a tool which can be used for various levels of learners. So we will start with a very small activity of GeoGebra which can be taught for small children. Okay, it is for products. I want to compare the product of two numbers. So this is an activity which is already it is in the resource pool. You need not construct a pool. Actually, it is already available. You can just use it in the classroom. There are plenty of such tools are there. So the question is, you want to compare 17 times 351 and 34 times 351. So you want to see, as a teachers, we know the answer. You can see the size and other things. There are actually, I can change the problems slightly. I can change width. Instead of 349, if I want to change something else, I can change here. Instead of 17, if I want, I can change something. Okay, I make it 19 times 354 and 38 times 354. How that we will do? We'll show the solution. We can guess, child can guess the answer. Then we can just show the solution. It is detailed solution is there. But now advantage is I am going to visualize this one. You see, you can see the blue colored strip. What happens to that blue colored strip? One piece of blue colored strip still not completed the larger one. The second one, now it is complete. So that is what we told. 38 times 354 is 2 times of 19 times 354. Suppose we want to try another one. We'll just click. Question is changed. Now if I want to show solution, 41 times 826. How many 41 times 826 is required to make 164 times 826? 1, 2, 3, 4. So this is one activity which even for lower class we can use this activity. Now coming to one more activity, this is how to draw angles using protractor. So the question is asking you to measure the angle 47 degree. So what I can do is I can move this protractor actually. I can hold the protractor and keep somewhere here. Then I can rotate my protractor. So I will make like this, baseline and protractor's bottom side is coinciding. It is asking for making 47 degree. So I can make, you can see that I can make 47. So what happens if I make 70 and check answer? No, answer is wrong, try again. This time I make here, try again. Now it is giving you a hint. Make sure to line up one of the sides angle along with the edge of the protractor. So 47. So I keep here. Is it 47? No. 47. Check. Correct. So this is a already inbuilt activity in the GeoGebra. Now let us see how quickly we can make another activity here. I will go to GeoGebra file. The GeoGebra has different interfaces, as its name suggests. It will have different interfaces here. You can see that one. I think you can see the screen, my screen. There is graph paper is there, algebra window is there. The word GeoGebra is actually a combination of algebra and geometry. That is why it comes here. So this is algebra. There are toolboxes are there. There are various toolboxes are there where you can explore various tools yourself, and tools are arranged in a systematic order. This is point toolbox. Various types of points are here. Some of them we will explore now. Line tools, perpendicular line tool, then polygon tool, circle tool, like these toolboxes are there. Also bottom there is an input bar is there where I can type if I want something to be typed there. Okay. Also there is a graph paper. Suppose you don't want to show axis, you can clear this one. Grid also you can clear, you can get a blank paper. Okay. What I am going to do is I am going to mark a point A as 0, 0. So it is showing unknown command. So there is something issue here. We will type A equal to 0, 0. I have not entered, but it is showing you the blue color there. That means this is correct construction. Earlier you can see RoboCompass and other thing. There was another signal was coming. It is not true. There is problem in the construction. Now I marked A. Then next thing what I am going to do is I am going to draw a circle. There is a circle tool. Circle with center and radius. Center, if I click, it will ask what radius I want. I will click on radius. So I got a circle. Okay. Then I can zoom it. I can keep the circle here. I don't want grid or anything. Anyway, one more point I will take here. That point I am taking it as 1, 0. So I got the second point B. Then earlier we see the Desmos, there was slider. Here also sliders are available, but slider we can construct here. Various types of sliders are there. I am choosing an integer slider here. It is going from 3 to 30. So its value will be n will take values 1, 2, 3 up to 30. Now this is the slider. Then what I am going to make is I am going to make an angle with the given size. It is easy in GeoGebra. GeoGebra is you just keep the mouse on the toolbox. Then it will show what exactly I want to do. You have to select the leg point, vertex and enter the size. So I will click B. Then I will click A. It will ask what value I should type. So I am typing 2 pi by n. So you got 120 degree angle here, and there is a another point B prime is available here. You can see B prime here. I can hide this one by going here alpha. If you don't want to show, you can hide this one. Now what I am going to do is I am going to draw a polygon. I am going to draw a polygon B. So there are different types of polygons tools are there. One is polygon and regular polygon. I want regular polygon, all sides should be equal. So the construction is very easy. It will ask length of one base, and then it will ask how much should be your how many sides we want. So what I am going to do is I will click on B and B prime, then it will ask number of vertices. The number of vertices, I will give my slider value n. You see how this polygon is showing here. Okay. Now beauty of this construction is just click n equal to, change the slider. Again, you got a square inside this circle. So if I hide A, what I'm going to do is my rounding I am going to change. So you can see there is a polygon here, and area of the circle is pi, which is actually, we can give value of pi here. But at the same time, what I am going to do is I am going to define a text. Okay, before that there is something called area is there. I will click inside area. So area of polygon 1 is 2. Okay. I will click on the text box. Area of polygon is equal to, I want a dynamic text. That means as I change the value of the number of sides, it should change. What I should do here is, it will ask what I should link with that one. You can see here objects in that one, poly 1, you click. Now area of polygon is 2. Now we will change the value. You can see the area of polygon is changing. You can see this point, this is changing. Okay. So actually this is one idea when we say that area of polygon, the circle's area can be approximated through the areas of polygons. So this activity we can show to the students. Actually, you can see that I took only minimum time, less than 5 minutes to 10 minutes to construct this applet. So it will not take much time in the classroom also. Similarly, various activities we can show here. One more I will do quickly. I take a graph paper, then this time what I am going to do is I am going to draw x square. So graph x square, earlier I have constructed x square, similarly I got x square. Usually we will ask the students that if this is x square, how, if I add 2 to that one, what will happen? That is, what will be x square plus 2? How does the graph will look like? So if you ask the students, they will give many, sometimes they will give many answers, and we have to convince them that what is actually f of x. Y equal to f of x means y is your y coordinate. That is always give you height in these cases, in this type of function. So what I am going to do is I will take f of x plus 2. Enter. You can see what happens to f of x plus 2. The next question we can ask the students is, okay, if you add 2 to the function, its height is actually changing. Height is increasing. If you add minus 2, height will come down. That is, it will come down to the side. So instead of that one, suppose you tell f of x plus 2. In place of x, if I make x plus 2, what will happen? So let us see here, x plus, if I add normally in classroom, what I used to ask the students that, okay, guess where it will go. Then they will have many guesses. The right guess is this. So it will go to the left side. It is not x plus 2 does not go to the right side. Actually, it is going to the left side. Advantage for this one is, this construction is, I can keep an input box here where I can give function, and I can make function equal to x square. Now, if you want to edit here, I can go and edit at this place. You can see sin x. I did not do any, all the construction I have not done. I just changed here. So this is the red one, which is sin x plus 2. The blue one is sine of x plus 2. Suppose you want to do something here like 1 by x. You see, 1 by x is coming like that. So this much fast you can construct this one. Actually, this GeoGebra workshop usually should be have a hands-on with 5 days, or even then CIT is also organizing online sessions on GeoGebra. Exclusively GeoGebra sessions are there. So I hope my participants, those who are interested, can explore more in that GeoGebra, and they can even do it in the classroom also. They can try in the classroom. So these are some constructions which we have done. Now, at the last part of that one, this since we have very limited time, we have come across there are plenty of other open source tools are there. Some of them are beyond the scope of school education, but even it is a very useful one. Like Sage Math is there, which is actually open source one, and Maxima is there. Then Octave is there. Octave is actually little higher level. Tech Math is there. It is actually and other things, game oriented things are there. GNU Plot is there. Like that, there are plenty of tools are there. So you can explore those things. Our viewers can explore those things themselves. So with this one, I think, shall I conclude, madam? Any questions? We have. Should we go for questions?
Sure, sir. We have received certain questions from our audience's end.
Okay. Shall I close my presentation?
Sure, sir. Sure.
Sharing screen?
That's okay, sir. Let it be. I would like to thank you on behalf of everyone for explaining these tools, these free and open source softwares, that is GeoGebra, Desmos and RoboCompass. We have received certain questions, so shall I ask you?
Yes, ma'am.
Okay, we have
Happy
an
to
expert,
hear from you.
Sumandra Roy, and he's asking, how do we know which command has to be used in RoboCompass for drawing different geometrical figures?
Yeah, okay. Actually, there is a help is in this one. I will show that one.
Okay.
Here, I think you can see my screen now. It is fortunate I did not close my screen.
Yes.
So
yes, sir.
it is there. There is a how to is there on the right side. Okay. So if you click, it will show you the commands. What are the drawing commands here? Okay. It is saying that there are 10 drawing commands for RoboCompass, and along with that one, there are some helper commands are there. One more thing, it is actually in working. People are working on this one. It is actually getting modified. You see, this is what I have done. 0.34, a is equal to 0.34. Then it will draw this one. Line, how the line should be drawn. What are the properties? Line AB3. Length can be optionally given as 3. Line AB3, where 3 is the length of the segment. So like that, there are commands are there. You can see different commands here. This distance command only I have explored with the limited time. I can explore few things only. So I go through only few commands on this one. So these are the some command help box. Also there are worked out examples are there. You can see how bisect an angle. So there is a command is there. You can see how this bisect of angle is there. You can see the construction. It is already constructed one, but at the same time, right side you can see the construction. They are marking the point. So like that, you can explore these commands in directly going there. You can explore these commands. Similarly, for Desmos also we will have command and helplines are there where you can explore yourself. GeoGebra also will have available. Also at the same time, there is a lot of manuals are there in GeoGebra and others regarding this one, which help you in doing this one. So these are the some tools which I have not explored in our my presentation, like compass. It is there. Normally, this construction of RoboCompass uses the compass straighted construction more. That is actually pure mathematical construction, we say. They used to not measurement construction. Measurement constructions is comparatively less, but we can use that also. I hope that they can explore these tools themselves now.
Absolutely, sir. I think Mr. Roy has got the answer that he was looking for.
Yeah.
Thank you so much. And we have another question by Shiv Kumar, and he's asking, can we use Tux Maths for the school students? Could you please explain the tool? So you have mentioned this tool in the other tools apart from the 3 tools that you have explained. So would you like to give us a little detail about Tux Maths?
Yeah, actually, what we can do is they can explore those one. It will take little time for me to explain those things.
Okay.
Because we have to open. I have not demonstrated any particular activity with Tech Math, but it is actually very much useful for, especially for the lower class. Tech Math is very much useful for that one. It is an arcade game type of thing, but it is free and open source one. So they can, I think they can Google it and find out some information. That one demonstration is difficult at this time because we have very less time in that one.
Sure, no issues, sir. And we have another question, and the viewer is asking, is it mandatory for users to log in to use these open source softwares,
Yeah,
be it GeoGebra or
no.
be it Desmos, any
No,
one
actually
of them?
not required. We can work out in without logging in these things. But at the same time, if you want to save the work, you should have login. And GeoGebra actually it is a downloadable. Actually, I am using the downloaded version of GeoGebra. I am using Classic 5 version. There is Classic 6 version is also available. So you can. It is actually I will show you the Classic 6 version which is downloaded here. It is actually almost similar like Desmos interface, but it is little more powerful than Desmos in this aspect. So we can see that one here. This is see, all features are same. This is Classic 6 version, so it can be downloaded. And advantage for that one is you can download it in any platform. You can do it in any particular platform. And there is no presently my system is Ubuntu system. We can work it on Windows also, so no issue. And also mobile version is also available for GeoGebra. So there is no need to download this one. But when you are downloading, means when you no need to log in always. But when you are logging, if you are a registered one, you can save your works in that one.
Okay. So the mobile version is available for GeoGebra, but
yes,
not
GeoGebra
for
mobile version is available.
And for Desmos and RoboCompass?
No, they are not. It is not this one. Desmos, I think it is not possible. RoboCompass, I have not tried in mobile version. Actually, what in classroom, what usually happen is more than mobile version. We will be comfortable in laptop system versions because mobile versions are actually very small. So I have not tried with the RoboCompass and other things. Yeah, RoboCompass is actually browser based one. You are working on browser only, you are not downloading anything there.
All right. Thank you so much, Dr. Madhu, for being with us today. It was a wonderful interaction indeed, and we have got all the answers, and you have explained all these tools pretty neatly and smoothly. Thank you so much for being with us today and for giving us your time. Thank you.
Thank you, ma'am. Thank you.
Thank you to each one of our viewer for raising your questions, your queries. That just shows that you were very much interested in the entire session and you enjoyed the program. So with this, we have come towards the end of our session, and it's time for me to show you that how you can register yourself and how you can participate in this entire online training. So this is the website you can see on your screens. All you have to do is type CIET on any of your browser, and once you do that, just click on the website, and this is the home page that you can see. So you can see the menu bars, and if you'll click on the activities topic, you will see multiple options. The third last option is workshop/training. If you click on it and scroll it a little down, you can see in the current activity the online training on ICT for teaching and learning of mathematics is mentioned. Please click on it. It's a clickable link. And here is each and every detail regarding this online training. The title has been mentioned, the schedule has been mentioned from day 1 to day 5, that is 14th of October to 18th of October. What all topics are we going to discuss? Everything is mentioned here. Who all can participate is mentioned here. What are the main objectives of this entire training? You can read it out, and the program schedule from day 1 to day 5 has already been mentioned. So once you scroll it a little bit here, you can see the registration link. If you can click on this link, a form will open. Just fill in your details and submit. You will be registered, or you can scan this QR code and fill the form, register yourself. So this is the YouTube channel of our program NCERT Official. If you click on it, you will see the videos, the programs that were done yesterday and day before yesterday. That was the day 1 and day 2. You can simply watch the programs that you have missed. And if you scroll it a little bit more down, here is the recording using the playlist link. This is the direct link of the playlist where you can see the videos of day 1 and day 2. And this is the main step where you can see that the online course link will be given to you, but not today, on the 5th day. You can join the online course that will be launched on Diksha portal. The course link will be updated on the event page on the last day of the training by 7 p.m. And this course will be open till 30th of March 2025. You all, that is participants, need to join the course, go through all the 5 videos, and the participants need to take up the final assessment. Participants can attempt thrice this assessment. Participants who score 70% and above in the final assessment will get a certificate, and they can assess their certificate in their Diksha profile page itself. It may take 15 to 20 days to receive the certificate. So please have some patience. And here you can see the feedback link is also mentioned. Just click on it and submit your feedback. If there is any suggestion, any advice that you have for all of us, please submit it. Or you can simply scan this QR code and submit your feedbacks. And here is the specific email ID that we have, training.helpdesk@ciet.nic.in, where you can raise your queries not just during the program but later on as well. With this, we have come towards the end of our program, and tomorrow sharp at 4 o'clock we'll come back again and we'll discuss the topic for the 4th day, and that is going to be immersive technologies for the teaching and learning of mathematics. So please watch the entire program and raise your queries just like you did today. And after that, we are wrapping up this particular program. But yes, there's another program as well lined up for you. The next program is Sahyog. And the title that will be discussed in the program is going to be Career Paths in the Digital Age, Skills That Matter. So with this, we have come towards the end of this program. Have a nice day ahead, and keep on watching our YouTube channel NCERT Official. I'm Tanvi Khurana, and I'll take a leave of you. Have a great day. Namaskar.